Or like this is a lot
Another
better.
good show on Netflix is called The Circle. I don't know, it's definitely entertaining.
Recording has started.
All right, recording started. All right, guys, welcome back. This is today's Wednesday or Thursday? Today's Thursday. Wow, time is flying by this week. Thursday. This is going to be day 4 of our review. As far as I know, we're going to have review tomorrow. Just check your Class Connect session if we do or not. All right, this is where we left off at, right? I think so.
Yes, we did. How's that Sarah's question?
Okay. Yeah, I think from these on, I think they're a little faster than the previous ones. All right, so it looks like we're in Unit 5 now. So fresh stuff. All right. Sarah plots 3 common negative pi on the polar plane. She first determines which line the angle of rotation places the point on. This line tells Sarah that the point must lie on the blank if r is positive. So we had this question on our test, our Unit 5 test. So these are the choices you have here. Positive x-axis, negative x-axis, positive y. Okay, positive y-axis, negative y-axis. All right, A, B, C, D, go in the blank. All right, so we have, remember, this is r comma theta. So again, going back to the problem here, says the angle of rotation places the point on blank. So it's telling us to ignore the r value for right now. So negative pi. Well, negative pi, we start, remember, at 0. And because it's negative, we rotate clockwise. Pi. So in this case, because it's pi, it doesn't matter if we rotate either direction. We end up at 180 degrees, right? Pi radians. But this value could be like, I don't know, pi over 6. So it could be negative pi over 6 or positive pi over 6. And you'll have to make sure you rotate the correct direction. Hopefully on your unit circle, you wrote maybe an arrow going this direction and showing that's negative, and then rotating counterclockwise, showing that's the positive direction. You gotta be careful. But in this case, we're rotating negative pi. So we rotate clockwise a full pi, which is half rotation. And this says that we must lie on the blank. So where are we? So if r is positive, which one is it? The negative x-axis. Yes, we're definitely going to be on the negative x-axis if r is positive, which it is. So let me go to this page. Yep, negative x-axis if r is positive. Now, if r was negative, let's say that was negative 3, even though we rotated clockwise, a rotation of pi, if r was negative 3, what would it make us do? What would it make us do? So if your r value is negative, what does it make us do? It makes us rotate another 180 degrees, right? So that would flip us over here, which means that blank, I see a lot of you in chat already put positive x-axis. Yep. All right, so the radius of 3 tells Sarah that the point lies on the third circle of the polar plane, which is, third one. So 1, 2, 3. The value of r is positive, therefore the point will lie on the blank. Because r is positive here, what is that last blank? It is negative x-axis. Very good. So this problem's not very difficult if you understand, you break it down, you understand what's going on in terms of rotations and how negative is rotating clockwise, positive is rotating counterclockwise. A positive R value, you don't change it once you rotate. If it is a negative R value, you just rotate 180 degrees. So the diagonal. But this question was on last test. It'll be on your final as well. All right, another simple problem, I think. All right, so it says how many petals, and what are the lengths of the petals of the following equations? So you'll be given an equation, quite possibly, and you have to determine the length of the petal and also the number of petals. And there is a little formula in your notes. And I think did I paste it on here? I did not paste it. So you might want to check your notes, 502 day 2. There's something about this number being even or odd. Does that sound familiar? Even or odd? So this one's really easy. The amplitude. This determines what? Yeah, the length. So those are all pretty easy. You can really fill those in. So length of 4, length of 2, length of 5, length of 6. Yep, those are really straightforward. But in terms of the number of petals, it really depends if it's even or odd. Okay, so if it is odd, like it is, how do you find the number of petals? Do you remember? If it is odd, what do we do? Well, so you can probably think of there's two choices, right? Either you multiply by 2 or you just leave it as is, right? Those are really the only two choices, if you recall. But which is which? If it's odd, do we leave it? Or if it's odd, do we multiply by 2? Hmm. And yeah, any guesses? Preferably the right answer. Crickets. Crickets, crickets, crickets. Oh, wait. I had to scroll down. My chat was frozen. Yep, Naya's right. We leave it. Yeah, if it's odd, leave it. Yeah. So because the K value is 3, well, we leave it as 3. So odd, you stay the same. And if you think about it, if you always multiplied by 2, so let's say you thought multiply by 2 if it's odd and leave it if it's even. That means you will never have a scenario where you have an odd number of petals, because an odd number multiplied by 2 makes it even, and then every other even number stays the same, so it's also even. So you're always going to have even petals if you think of it that way. So if you think about having variations of petals that have an even or odd number of petals, well, the only way to get that is to leave odd K values alone, and then you would double even values, if that makes any sense in my logic. So just to make it short and sweet, if it's odd, leave it alone. If it's even, double it. So that's 4. That 4 is an 8, and then that 5 is a 5. All right, we good on this one? All right, next one, convert equations. So we have which equation? I'm sorry, which equation? There's not even a choices here. All right, which equation is the polar equivalent to the equation y equals negative rad 3x? This should probably say find the equation, find the polar equivalent to this equation. All right, so how do we do that? How do we convert this from rectangular into polar?
Wait, do you mean parametric or is that a totally different thing?
So there are parametric equations, but there's also polar equations in this unit.
Okay, let me look back at my notes. I found the parametric ones, but not the polars yet.
Polar is that previous page. So this is an example of a polar equation.
Okie dokie.
Polar is when you have that circular graph and you have radius and theta.
I think I found it. Polar. Can I say the polar form's like base formula or base setup and see if it's right?
Sure.
Z equals R cosine theta plus I sine theta. Is that right?
So that is polar, but that's for complex numbers.
Well, that's awesome.
Does this help you, Antonio?
Not really. But I'm gonna say yes.
Oh no. How quickly we all forget. And this was this most recent unit. Your test was this last week, right? Yeah.
So you made me go back like 5 units in a matter of 4 days.
No. No.
Yes.
No.
Yes. Yes. But the before after the vectors.
This was before vectors. Look, 5.04. This is like early on. All right. Well, some of you are confused. All you're going to do, I give you this little conversion here. You're just going to replace y and x with what they equal. X becomes r cosine theta, y becomes r sine theta, and then you solve for r. Yeah, yeah. All right, next up. Anybody? Let's do a poll. um, who's still here?
I promise I'm here. I'm just really trying to find these notes and I'm struggling to find them.
All right, some people are here. Kayla, Haley, not here. Sad days. Okay, so you don't need your notes. You just need to solve this equation now. So what do we do?
Do we square root it?
No.
Oh wait, I think we want to get these isolated somehow. All right. Do we like divide by r cosine theta and do this on this side?
That's what I did.
Okay, I'm not totally useless then.
So this is one way we could have done it. You could have added rad 3 r cosine theta both sides and then solve by factoring. So that would be another approach. And then once you factored it, you set the factors equal to 0. But this is how I did it. Avoid factoring. And now what?
We could convert them to x and y, but I don't think we want to do that.
Remember, our goal is to convert from x and y to r and theta for polar. So we're done using that box in the bottom right-hand corner. We just need to simplify this equation now. Yep, Julia's right. Sine over cosine is tangent. What about the r's?
Don't they cancel?
Yeah, they cancel out. Yep. So the r's cancel out, and then sine over cosine becomes tangent. Okay, now what? Arctan. Yep, arctan both sides. And then what is the arctan of negative rad 3? So you have to use your unit circle. Pi over 3? I agree. That's the answer. So we learned, if you think back to that lesson, remember we talked about equations in polar form that are in the form of theta equals some value. These make a straight line because we don't have a defined r value. So the angle is defined. R value is not, so r could be, well, an infinite number of points. So this creates a line, which makes sense because y equals mx, well, plus b being 0. This is an equation of a line, right? So we should expect our polar equation to also be a line in the form of theta equals some number. So if you thought about rectangular and polar and how they work, r equals something, that creates a circle, right? Theta equals some number creates a line. So knowing this is a line, we should know that we should get to something like this. All right, I don't have a problem for this page, and partly because I couldn't really think of an example without giving the answer away on the final. So I just pasted this slide. So just know the 6 scenarios of multiplying complex numbers. So on this presentation, we talked about these 6 different scenarios. a real times a real times imaginary, imaginary times imaginary, complex times real, complex times imaginary, and complex times complex. So you'll have a very, very easy problem on one of these scenarios. I think it's a word problem. It just tells you when doing this, what happens. And if you refer back to your notes, you could easily just select the right answer.
Or if you need reviews, go back to the recording from this day and watch that.
Nope, I'm not giving away the answer to this one. You'll have to look it up.
But the recordings, they're available for them to look at it if they need to refresh.
Oh, for that day, yes, but not
Yeah.
for today's recording.
Yeah, that's what I'm saying, though.
Right, right, right. All right, multiplying complex numbers in polar form. So, a question like this: 4 CIS pi over 6 times 2 CIS 3 pi over 8. How do we multiply these? I'm going to give all of you 2 minutes to do this. And this is recent. This is our last test. Ready to go. All right, I'm going to stop the time. I think all of you should be done by now. All right, what's the answer? Hmm. When multiplying, multiply the R values, you add the thetas. A CIS 13 pi over 24. Yep, right. right, number 43, or slide 43. All right, we have vector -4, -2, and vector 7, -1. It says represent vector A plus vector B using the head to tail method. Draw vector A and B, then complete the head to tail method and draw vector A plus vector B. This one I do. Okay. All right, anybody want to take a stab at this?
I can.
Julia, go for it.
Me.
You don't have tools, does it?
I just gave it to him now. I
Okay.
gave it to him right now.
All right, thank you.
You're welcome.
I thought I had it turned on already. Are you trying to draw? Oh. Julia, is it not working for you? It won't let you? Huh. Antonio's, you're, hold on, let me just make you an admin, Julia, and it'll fix it. All right, now try it. Oh, fuck, huh?
That cat likes the screen time a lot.
Saw that, huh?
Yeah, you can see the tail is moving behind you.
All right, let me just show it then. It's like drawing's not working.
Okay, I could have done it, but okay.
All right, go for it.
Okay, so first we're gonna do 1, 2, 3. First we're gonna do this like that. That's one of them. That's gonna stay there. Then we're gonna do 7, -1, 2, 3, 4, 5, 6, 7, -1. So that's somewhere like that. That's gonna be moved. Then 4, -4 plus 7 is +3. And so +3, down 3, 1, 2, 3, 1, 2, 3, 6, 7. That was a little short, but so now we move this to there, that to there, and then my drawing's a bit off, but these two should be connecting right here because this goes a little more down.
A lot off.
Really?
Well, yeah, they should be touching.
Oh, but it was correct. Wait.
Yeah, yeah.
Where did this
So
come from?
that's your B vector. So you had to draw your A vector, your B vector, and then for the head to tail, you basically slide this over to here, right? And then make sure your arrow is pointing here, and then your A plus B is from the origin to that point. So this is what you should have on your graph.
To clarify, that was correct. Just way off.
Yeah, it was way off. It was not correct. By definition, it was wrong. By definition, if you're way off, it's not correct. Yeah, actually, Antonio, this would have been totally correct if it wasn't way off. All right, next one here. So what is the component form of the vector represented by -2a when vector A is -2, 3? All right, I'm giving all of you 30 seconds. Ready to go. All right, what's the answer? -6. Agree? Or -6? Ooh, Makeda forgot her chevron brackets. Wrong. And then Julie, you forgot one of your chevron brackets. Wrong. But I get what you're trying to say. Yeah. So this is a freebie. Nobody should miss this problem on your final. Freebie right there. Left. Do you want to finish this tomorrow or right now? Enough time.
Well, I mean, if we don't do this tomorrow, we pretty much won't have class tomorrow. There's no reason we have like no questions left.
True, maybe. Save these last two for tomorrow, and then I'll do something else tomorrow for review as well. We only got 2 problems left, but we'll stop here. All right, guys. Well, thanks for coming, and see you tomorrow for the last couple problems.